Okay, question number 4 asks us to find the inverse of this function. So in math class, what I teach my students is to find an inverse would be to two steps, switch x and y and then solve for y. And you can see that's pretty difficult here because if you do that, you're going to have y in a couple places, and it's not going to be very convenient, especially since we're trying to average 2 minutes per question on this exam. So instead, what would be very nice is if we go ahead and graph this. Notice I'm putting parentheses around the numerator and denominator. If you don't, your calculator is going to do order of operations, and it's going to do it in a little different order than you actually want. So here's the function that we have. Now, one of the characteristics of inverse functions is that they have a line of symmetry at y equals x. So I'm actually going to also graph y equals x when I'm on the same line. And so if I take this function and flip it over this line, that's going to be the inverse. Well, looking at these equations, I don't really see, I can't tell which one that's going to be. So I would just do some process of elimination here. I would just try choice A, and if it looks like that y equals x is a line of symmetry, then I would pick it. And that actually looks pretty good. If I flipped over, the calculator doesn't have color here, but if I flipped over that first function over y equals x, it looks like it lands on the other one. Now, that was just lucky. Probably not always going to get it on the first try like that, but short of spending more time trying to solve this algebraically, I think this is the approach that you want to go. Graph the function, graph y equals x, and then graph each one of these until you figure out which one had a line of symmetry at that y equals x.